Hi, so I'm here today to talk to you, teach you, educate you about the circle. As you can see here, it's a set of all coplanar points such that the distance from the fixed point is constant. So there's a couple things to be specific that you need to really remember here. Like for number one is here the fixed point. That will be the center of the circle. This is the center of the circle. And the next thing is over here, this distance, the constant distance. This is the radius of the circle. Radius of the circle. So those are the two things that you really need to remember when solving for the parts here. So let's start. So for a circle whose center can be found at the origin or the origin of the Cartesian plane, aka the coordinates 0 and 0, the standard form will be over here. The standard form. It is x plus y squared is equal to r squared. As for the general form, it's x squared plus y squared minus r squared is equal to 0. So the way we got that is we transposed r squared to the other side. So r squared goes to the other side, you transpose it, so its sign will flip, it will become negative instead of positive, and because this side is now empty, it becomes 0. So that's how we got the general form of a circle at origins 0 and 0. Okay, so let's try to do some solving, I guess. So let's go here. So let's say we have our radius is equal to the square root of 5. So what we do here is we just bring down x squared plus y squared, and then we substitute r. It becomes the square root of 5, then copy the 2 squared. Then next we x squared plus y squared is equal to, so the square root of 5 squared, what you do here to make it faster is just simply remove the radical sign, and that will leave us with 5. There it is, that's our final answer. Yeah, that is our final answer. How about another one? This time for general form. It's honestly the same. Okay. Let's copy this over. Let's say our radius is equal to 6. So again, copy x squared plus y squared because their values aren't given. Minus r, you replace r, you substitute r with 6. 6 and copy squared and 0. So just bring it down, x squared plus y squared minus, so what is the square root of 6? On the square root of 6, what is 6 squared? We have 30, that was 2. 36 is equal to 0. There you go, that is our final answer. So let's move on to circles whose center can be found at h and k. So our standard form is over here. Let's read it together. X minus h squared plus y minus k squared is equal to r squared. So the difference here between a circle whose centers at h and k and a circle whose centers at origin is that these change. They're not just 0 and 0 now. That's honestly it. So let's first try to figure out, like, how did we get here? You know, there was a process that took us from the standard form to the general form last time, and somehow from this we suddenly have x squared plus y squared plus dx plus ey plus f. Like, how did we get here? So it is over here. So we started off with the standard form, right here, the standard form. Like in the center whose the circle's centers at origin, we transposed r, so it's over here. It became negative. Next we squared the binomials. We squared these, squaring binomials. Square the first term, multiply twice the product of the two terms, then square the final term. So over here we get this and we get this. X squared is x squared. X times negative h is negative h, then twice that, negative 2hx. Then square h is positive h squared. So after that we just combine like terms. So x squared and y squared, because they're the only ones with the variables. The variables the exponents. Then over here we combine these together because they're the ones with the exponent with the variables, and these. Yeah, you'll see. So how did we get here? So basically we just give them symbols. So 2h, negative 2h is d. We simplified as d. Negative 2k is e. And this long line is f. So when solving for the general term, you simply need to substitute d, e, and f with these. Yeah, that's it. So I think now we can start solving. So let's say our 8 and negative 5. Then our radius is equal to 4. Yeah, that should be fair. So let's do general form because standard form should be pretty self-explanatory. General form is probably where you'll be struggling. So let's copy the formula. Copy the formula. Then now we substitute. Again, x squared plus y squared. Then d is negative 2h, e is negative 2k, and f is h squared plus k squared minus r squared. Don't worry, we'll write it down. So let's solve for d. It's equal to negative 2h, negative 2h. So substitute, we get negative 2 times our 8 is over here, 8. So negative 2 times 8, it's negative 16. There. Then, so let's start writing it down. X squared plus y squared plus 16x plus, then let's solve for e. E is equal to negative 2k. So negative 2, then k is over here, negative 5. So negative 5, negative 2 times negative 5, 2 times 5 is 10, then because they have the same sign, it becomes positive, so positive 10. So 16x plus 10 y plus, now let's go solve for f. Right. Let's clear up some space here. Okay, so f will be, right, let's go back to the solutions. So f is over here. F is over here. H squared plus k squared minus r squared. So let's go back to solving. H squared plus k squared minus r squared. So let's substitute. H is 8 squared plus k is negative 5. Negative 5 squared minus r is 4 squared. So let's go, what is the square? Oh, what is 8 squared? It's 64 plus the square root of 5, 25 minus the square root of 14, 16. Now let's solve for this. 64 plus 25 is 89 minus 16. 89 minus, need some assistance. I don't have the sharpest mind. So 64 plus 25, 89 minus 16. Our f is 73. There you go. 73 equals 0. Now let's combine everything we got. So we're left with x squared plus y squared plus 16x plus 10y plus 73 is equal to 0. That is our general form. I think that should be it for me. Thank you for watching. Goodbye.